Hello students, welcome to the series of organic chemistry. Dear students, today we are going to learn about haloalkanes and haloarenes. These are the compounds having halogen, organic compounds with halogen. What are the halogens? Common halogens are, we come across fluorine, chlorine, bromine and iodine. So these halogens attach to organic compound, for example RF, RCl, RBr. If the R is alkane, then these compounds are known as haloalkanes. R is alkane, then it is known as haloalkane. If R is arene, then it is known as haloarenes. So these compounds are very important organic compounds in organic synthesis and chemistry, because these compounds, for example chloramphenicol is an antibiotic drug used for the treatment of typhoid disease. At the same time, chloroquine is a drug, synthetic drug used for the treatment of malaria. And the thyroxine is an hormone which is synthesized in the body with the help of iodine. Its deficiency causes goiter disease. And halothane, it is also one of the drug used for anesthesia, to give anesthesia while doing operations or surgery. So halothane is used as anesthetic drug. Yes students, so this is how these compounds, haloalkanes or arenes, are very important compounds in organic chemistry with respect to their importance. However, and most of the halo compounds which are also used as polymers, and however these compounds are highly environmental problematic, because these compounds are not digestible or break down by soil bacteria. Let us see its chemistry. Let us see what are haloalkanes. Commonly these compounds can be classified or named as based on the number of halogens containing. For example, this is ethyl and X. And dear students, before entering into deep, so halogen is denoted with capital X. X can be fluorine, chlorine, bromine or iodine. So usual manner of denoting halogens with respect with alkanes or arenes is X. X can be fluorine, chlorine, bromine or iodine. So the nomenclature follows mono, di, tri or tetra, or if it is more than tetra you can, or penta, hexa, hepta. So if the number of halogens are very large, then you can use as polyhalogenated compounds. Yes students, so depending on number of halogen atoms in their structure. For example, this is one halogen, monoalkane, dihalogen, dihaloalkane, trihalogen, trihaloalkane. These are alkanes. Yes, when it comes to aromatic compounds, this is monohaloarene and dihaloarene, trihaloarene, because it is substituted with trihalogens. Then the compounds containing sp3, the halogen can be attached to the carbon which is having sp3 hybridization, or it can be attached to sp2 hybridized carbon. For example, if it is attached to primary carbon, the carbon which is attached to 2 hydrogens, 1 alkane, or 3 hydrogens, then 1 halogen, it is known as primary carbon. So the halogen which is attached to primary carbon is known as primary halogen, and if it is attached to carbon which is the secondary, then it is known as secondary halogen and tertiary halogen. And the common formula for writing alkyl halides is CnH2n plus 1 into and X. So we know that for alkanes the general formula is CnH2n plus 2, isn't it? 2n plus 2. So when it comes to halogens, one hydrogen is replaced by halogen. So alkyl halides are the compounds which are having halogen in them. And allylic halides, this is very important concept, students. So halogen is attached to sp2 carbon. Here the carbon is sp2 hybridized, but the adjacent carbon, which is alpha beta unsaturated, this alpha beta unsaturated carbon is known as allylic carbon. And this allylic carbon, if it contains halide, then this halide is allyl halide. It is named as allyl halide, though it is having sp3 hybridized carbon. Yes, benzylic halides. Now benzylic halides are the compounds or the halogen attached to benzylic position. This is benzylic position. So this carbon which is directly attached to benzene ring is known as benzylic carbon. If the halide is attached to this benzylic carbon, then it is known as benzylic halide. So if it is primary, then primary benzylic halide. If it is secondary, secondary benzylic halide. Tertiary, tertiary benzylic halide. So this is benzylic, and it is very similar to, with respect to synthesis or with respect to its chemical properties, are very similar to allylic carbon. Yes, so to this carbon alpha beta unsaturation is present. So similar to allylic carbon, benzylic carbon also behaves during the synthesis as well as during its chemical properties. So this concept is very important, students. So allylic and benzylic halides. Next, and compounds containing sp2 hybridized. So for example, vinyl halide, yes, cyclohexene halide. So this is vinylic position. So directly halogen is attached to double bond carbon, then it is known as vinylic halide. So this is also vinylic type halide. And aryl halides. So this halogen is directly attached to double bond containing carbon. In benzene also vinylic type halogen is present. So this is aryl halides, and vinyl halides are nothing but sp2 carbon containing halogens. So this is how their nomenclature follows. Then nomenclature, yes, they usually we follow common names as well as IUPAC name. So in general synthetic lab, most of the times we follow common names. For example, N-propyl bromide, isopropyl bromide, isobutyl chloride. So when you follow IUPAC nomenclature, it is attached to 1 bromopropane. This is 2 chloropropane. Yes, 1 chloro, then 2 methyl. We have learnt nomenclature rules and regulations in our 11th class, isn't it? So 1 chloro and followed by 2 methyl propane. When it comes to halogen compounds, in haloarenes we have learnt that, so the compound which is with respect to this carbon, if it is 1 position, then 1 2 you can use 1 2 3 1 2 3 4 5 and 6, right? So common name is, this is ortho position, you can use ortho, and this is meta, this is para. So these are the positions. This is also meta, this is also ortho, meta, para, OMP, right? So in common names you can use it as meta dibromobenzene, meta dibromobenzene, or when it comes to IUPAC nomenclature, you have to give the numbering 1 and 3, 1, 3 dibromobenzene. So in this case 1, 3 and 5 tribromobenzene or tribromobenzene in common names. So most of the times when it comes to haloarenes, the common name as well as IUPAC name similarly pronounced. So bromobenzene, bromobenzene, dibromobenzene, dibromobenzene, tribromobenzene, tribromobenzene. However, you have to write the positions 1, 3, 5 or meta or 1, 3 like that. Otherwise, the common name and IUPAC names are very similar with respect to aromatic compounds. When it comes to aliphatic or alkanes, haloalkanes, the nomenclature differs. So N-propyl bromide, 1 bromopropane, isopropyl chloride, 2 chloropropane, like that. So when it comes to IUPAC name of this 1 chloro, 2 dimethyl propane, 2 bromopropane, and this is common name ethylene chloride and dichloroethane. So this is commonly used solvent in organic chemistry, ethylene dichloride. Usually it is denoted as EDC, ethylene dichloride. Yes, so 1, 2 dichloroethane. Like this you can nomenclate, and here it is given number of common IUPAC names of some halides. A secondary butyl chloride, 2 chlorobutane, neopentyl bromide, 1 bromo, 2 dimethyl propane, 2 bromo, vinyl chloride. So this is vinyl chloride, and this is allyl bromide. Yes, so allyl bromide, and orthochlorotoluene, chlorotoluene, or you can use as chlorotoluene or chloromethylbenzene. So benzyl chloride, this is benzyl chloride, students, benzyl chloride, and dichloromethane. Usually in common name also nowadays it is used as dichloromethane, and this is chloroform. Trichloromethane is also known as chloroform and bromoform, and tribromomethane is also known as bromoform. CCl4 carbon tetrachloride, and this is N-propyl fluoride and 1 fluoropropane. These are all the common names we come across during our laboratory. Yes, so when it comes to board exams, you will be asked to write the nomenclature, you will be asked to write the IUPAC names of these compounds. So to practice, yes, you can write like this, and moreover you must be able to find out the primary carbon and secondary carbon. For example, so this is primary carbon and this is also primary carbon, whereas remaining 3 carbons are these and these are secondary carbons, isn't it? So if I ask you the 8 structural isomers that have molecular formula C5H11Br, name each isomer according to IUPAC name system. Yes, students. So when it comes to your board exam, it is very important, even with your JEE and NEET also. So 1 bromopropane, 2 bromopropane, 3 bromopropane. So up to here it is 1 series is complete, right? Then you have to change the methyl groups position, 1 bromo and 3 methyl butane. So bromo, alphabetical order it follows, bromo methyl, right? 2 bromo, 3 methyl, 2 bromo, then it is 1 series followed by 2 bromo, 2 methyl, and 1 bromo, 2 methyl butane, and 1 bromo, 2 dimethyl propane. Like this you can write the number of examples. Write IUPAC names. So this is very important, students. Please practice. So how to write 4 bromo pent 2 in. So before numbering anything, before giving the nomenclature, write the longest chain. Choose the longest chain, 1, 2, 3 and 4, 5. So now we are thorough with the number of carbons. How to give nomenclature? 4 bromo, functional group is 4 bromo, pent, and 2 in. This is 2 in. It is not 1 in. It is 2 in. So like this you have to choose the number of carbons first, then give the name. And when it comes to this compound, 3 bromo 2 methyl 1 in, and 4 bromo 3 methyl pent 2 in, and 1 bromo 2 methyl butene. So the key factor is you have to choose the longest chain. 3 bromo 2 methyl propene. Like this you can give the nomenclature, right? So write structures of the following compounds: 2 chloro 3 methyl pentane, 1 chloro 4 ethyl cyclohexane, 4 tertiary butyl. Yes, you can write the names. Based on the names you can write the structures. So for example, when it comes to compound 2, 1 chloro, it is very important, students. So how to write? 1 chloro 4 ethyl. So in cyclohexane also you have to give like this numbering: 3 and 4, 5 and 6. 1 chloro 4 ethyl cyclohexane, 4 tertiary butyl, 3 iodoheptane, 1 2 dibromo-2-ene. So when it comes to this secondary, this is secondary carbon, it is attached 4 bromo, 4 secondary butyl, 2 methyl benzene. So like this you can give the nomenclature. Then comes chemistry. So what is the nature of the CX bond? Yes, so this halogen is attached to carbon. We know that halogens are highly polar, so that is why, and electronegativity of halogen is more than the carbon. Yes, so electronegativity is more than carbon. So halogens are polarized, so delta negative it will have, and this is delta positive, isn't it? So carbon halogen bond lengths, bond enthalpies and dipole moments. Dear students, so as we know, moving in a periodic table from top to bottom, the bond length of CX increases, isn't it? Increases. So fluorine is bond length is just 139 picometers. When it comes to chlorine, 179, 193 and 214. This is how bond length increases and enthalpies decreases. This concept is very important, students. Bond length increases, I can write bond length increases, and enthalpies decreases. Enthalpy delta H decreases. From moving from top to bottom, enthalpy decreases. So this concept is very important while writing entrance exams. Yes, students. So for example, fluorine 452 and methyl iodide it is 234. That means it is decreasing, isn't it? Yes. Next. And methods of preparation. How to prepare these compounds? The usual manner of preparation of alkyl halides is from alcohols. So we have alcohols, ROH, primary alcohol, secondary alcohol, tertiary alcohol, whatever may be the alcohol. You can directly treat it with HCl. You will get alkyl halide. However, this is not that simple. So treating with HCl requires catalyst and temperature. Yes, so you can treat it with sodium bromide with respect in presence of sulfuric acid. Another method is you can treat it with sodium bromide in presence of acid catalyst to give alkyl halide. This time, so one key factor. So when I am using sodium bromide, I am getting sodium this alkyl bromide. So you may get a question like this: can I use sodium iodide in presence of sulfuric acid? What happens? What happens? So for example, it is CH and this is H, whatever with the H or anything, here H and R. So when I am using sodium bromide, this halogen is replaced or substituted with bromine. But when I use sodium iodide in presence of sulfuric acid, what is going to happen? H2SO4. So this H2SO4 gives H plus ions and forms a salt with sodium, right? So the H plus ions which are going to be replaced with this H hydrogen, sodium, not sodium iodide, it is iodine. If I use iodine here, so it is going to react with this hydrogen to give Hi, and this Hi is not going to, and this Hi is going to take, is going to replace back with hydrogen. So it is not used, iodine is not used in presence of sulfuric acid. Yes. However, if you want to use iodine, you have to add HiO4 or nitric acid to get it back as iodine. So like this you can do this. Yeah, anyhow. So common methods for the preparation of alcohols from alcohols, haloalkanes is from alcohols. So you can treat it with HCl, sodium bromide, and phosphorus trichloride at tribro PbR3. Yes. So PCl5, and this is red phosphorus and halogen. In presence halogen, red phosphorus, this HVZ type reaction, HVZ, Hell-Vollard-Zelensky reaction. You can do HVZ reaction. So HVZ reaction is the halogenation of carboxylic acid, alpha halogenation of carboxylic acid you can do with red phosphorus and halogen, isn't it? So HVZ reaction. And however, the common method used in organic chemistry synthetic laboratory is treatment of alcohol with thionyl chloride. So thionyl chloride method is the best one among all these methods, because the side products which are coming out from the reaction is sulfur dioxide is a gas, HCl also is a gas. So these gases will evaporate from the reaction mixture, and the leftover will be the pure alkyl halide, So this is how haloalkanes can be prepared from alcohols by treating with thionyl chloride. Next, from alkanes by free radical halogenations. During alkanes chapter we have learned that free radical halogenation can be done in presence of chlorine and UV light. This concept is very, very important, students. So chlorination can be done using UV light. However, bromination is sluggish, and iodination you are not supposed to do with this method, right? So however, from alkanes free radical halogenation, what is happening? It is going to give mixture of compounds. For example, 1, 2, 3, 4, 1 chlorobutane and 2 chlorobutane, like this mixture of compounds we are going to get from alkenes. So alkenes, it is common method where you will get Markovnikov's product. This concept is very, very important. Markovnikov's product. Markovnikov product is the compound which undergoes addition reaction, where the nucleophile, incoming nucleophile, adds to the carbon having less substituted carbon. So this is, for example, if I take this alkene and HX, it is hydrogen and X, whatever may be the X, either chlorine or bromine, it is going to add to H plus first to give, for example, this is carbocation. This carbocation will be attacked by nucleophile, right? So nucleophile, it will attach. It is a Markovnikov's addition, where the nucleophile adds to the carbon which is less substituted, is known as Markovnikov's product. Markovnikov's product or Markovnikov's rule. Yes, students. So this is also very, very important when it comes to this alkene, unsymmetrical alkene. Now, so when it comes to HI, it first adds to hydrogen to give, here what is going to happen, here it can give carbocation, let me write in detail, CH3. So this concept is very, very important, students. So Markovnikov's concept you have learnt in detail in your 11th class. However, let me explain. So it can add to 2 carbons, isn't it? It can add this hydrogen. Let us add this hydrogen to here. What is going to happen? It is going to form primary carbocation. If it adds to this CH, it is secondary carbon, and CH2. Here if it adds to this carbon, the carbocation formed is secondary carbocation. We know that this is secondary carbocation and this is primary carbocation. And which is more stable among these two carbocations? Secondary carbocation is more stable. Now the iodide which is there in the reaction mixture, iodine minus, which is there in the reaction mixture, will add to the carbon which is there as major. If it is secondary carbon, is since secondary carbocation is more stable, it is formed major. So iodide will attack to this secondary carbocation to give this 2-iodopropane as a major product. When it comes to here, it is, if it adds to this carbon, it is going to give 1-iodopropane, which is minor compound, because this is anti-Markovnikov's product, whereas this major product is Markovnikov's product, where the incoming iodide or nucleophile is adding to the carbon which is less substituted with hydrogens or alkanes, isn't it? So this is secondary carbocation is more stable. We are going to get unsymmetrical alkene. We will get Markovnikov's product with respect to halogenation. Yes. So the addition of halogens. Yes. So bromine in CCl4 test. Alkenes gives bromine in CCl4. So you can prepare vicinal dibromide or vicinal halides where this bromine Br. So similar to above reaction, Br plus and Br minus, I can write this bromine delta positive and delta negative. It will add trans to the each one. So we will get trans 1,2 dibromo compounds. In this case, it is vicinal dibromide, vicinal. So if the halogen is attached to two adjacent carbons, then it is known as vicinal. If it is more than one carbon, adjacent carbon, then isolated dihalo compound. If the halogen is attached to the same carbon, then they are known as gem dihalides, isn't it? Right. So halogen exchange, there are mainly two reactions. For example, this is Finkelstein reaction where lower halogens, for example chlorine, can be replaced with bromine, or chloro or bromo compound can be replaced with iodine. Just simply treating with sodium iodide, take alkyl halide in dry acetone and treat it with sodium iodide, and you will get alkyl iodide compound, and the remaining this sodium halide which is going to form this chlorine or bromine are insoluble in acetone. So this is how it is not going to get back this reaction. So the key factor is use of dry acetone. Yes students, when it comes to fluorine, you can do fluorination using this sodium. Finkelstein reaction is not useful for the preparation of fluorocompounds. However, there is another reaction or use of metal fluorides like silver fluoride, HEgF2, cobalt F2, or stibethane trifluoride. So you can exchange halide with fluorine. This reaction is known as Schwarz reaction, similar to Finkelstein reaction. If the fluorine you are going to replace, it is known as Schwarz reaction. Yes students, so this is all about haloalkanes. Let us see, yes, before moving further, let us see some questions. So identify all the possible monochloro structural isomers expect to be formed on free radical monochlorination. So it is very simple. Monochlorination 1-chloro, you can make this 2 chloro. Here also you can form, and here you can work out, students, on your own. Yes, when it comes to aryl compounds, the same methods. For example, if I have phenol, since we are preparing alcohol to halides, this phenol is also similar to alkyl halide, and if I treat it with thionyl chloride SOCl2, am I going to get chlorobenzene? This method is not useful. Because phenols are strongly attached to this carbon, because presence of this lone pair electron, it is similar to some double bond character. So this double bond character CO bond is very tough to replace or substitute with chlorine. So phenols will not give halides with thionyl chloride, PbR3, whatever the reagents we learnt here. So phenols are not going to form alkyl halides or aryl halides with HCl, sodium bromide, So all these reagents, PbR3 also, are not going to convert phenols into halogen compounds. Then what are the methods available for the preparation of aryl halides? So aryl halides are prepared in a different manner. For example, if you want to prepare chlorobenzene, yes, you can treat it with chlorine or bromine. If you want to, let us take bromine. So when it comes to alkene, what we'll do? Bromine in CCl4, alkenes gives bromine CCl4 test, right? So alkenes decolorizes bromine in CCl4. When it comes to aromatic compounds, bromine in CCl4, if you add, it is not going to decolorize. Bromine in CCl4 itself is not going to decolorize. However, you have to add Lewis acid like ferric chloride or ferric bromide or iron. You have to add so that it undergoes electrophilic aromatic substitution. Where it undergoes aromatic halogenation, right? You can take bromine or chlorine, then you will get this aromatic substitution. At this stage, the same question comes. If I use iodine, what is going to happen? It is going to so this Lewis acid, you can if I write sulfuric acid, what is going to happen? It will form HI, and this HI is going to push the reaction backside. So to avoid that, we will use HiO4 or HNO3, right? So the very important reaction for the preparation of aryl halides is from amines. Sand-Meyer reaction. Sand-Meyer reaction is very important, students, even with respect to name reactions also. What is Sand-Meyer reaction? Yes, displacement of diazonium chloride with diazonium nitrogen with halogen is Sand-Meyer reaction. So we know that. Yes, anyhow, in further chapters you are going to get amines chapter. You can prepare diazonium chloride or diazonium salts, simply taking the aniline. This aryl amine is known as aniline. This aniline taking in mineral acid, for example HCl, in water HCl, it forms salt. Then add sodium nitrate at -5 degrees centigrade. It is simply 0 to 5 degrees centigrade. It forms diazonium chloride salt. This is benzene diazonium halide. This benzene diazonium halide, upon treatment with cuprous chloride or cuprous bromide, it is going to exchange or displace this nitrogen with halogen to give aryl halides, chlorine and bromine. Just now what I said, this Sand-Meyer reaction iodine usage can be done with simply treating with potassium iodide. Yes, iodine easily replaces or displaces nitrogen even with potassium iodide. So in this Sandmeyer reaction, what we are going to get? Chlorine, bromine and iodine compounds can be done. Aryl chlorides, aryl bromides or aryl iodides. When it comes to fluorides, so there is another name reaction, Schumann reaction. So Schumann reaction uses HbF4. So HbF4, or you can use sodium tetrafluoroborate. Sodium tetrafluoroborate. So simply make diazonium salt, then treat it with sodium tetrafluoroborate. You are going to get aryl fluorides. It is very, very important, students, Schumann reaction. So Sandmeyer reaction, when you are learning Sandmeyer reaction, please learn Schumann reaction also. It is the reaction used for the preparation of aryl fluorides. Yes, students, you have been asking some questions. Very good. You are new and Ansari, sir, please explain SN1 mechanism. Yes, students. So after this topic, we are going to learn SN1 and SN2. Don't worry. Next. So Schumann reaction. We are coming in a stepwise manner. Next, let us take some questions. So just now what I said, this is simple HBr and alkene. What is going to happen? It undergoes Markovnikov's addition, where H plus adds to this primary carbon and the secondary carbocation later will add to bromine to give this bromine. It is very, very important, right? And Markovnikov's product. Here also Markovnikov's product. Yes. When it comes to this peroxide concept, what is peroxide concept? Peroxide is Kharash effect. This peroxide reaction gives anti-Markovnikov's product, Kharash effect or Kharash, which was first observed use of peroxide. This peroxide reaction follows free radical addition reaction. Free radical, yes. So in NEET 2020, this reaction was asked. So in this case, it is going to attack, or bromine is going to be attacked at this primary position. It is not going to attack onto this carbon. Yes. So because of peroxide effect, it follows free radical reaction mechanism, where the free radical homolysis forms secondary carbocation, which adds first to bromine, right? So to give this primary bromide, Kharash effect. Yes, it will be asked in so many entrance exams or in your exams. So this, suppose phenyl propene, if I use HBr in presence of peroxide, I am going to get this. And if I want to make bromine at this position, what I have to use? Then simply use HBr, don't use peroxide. Then this is one question. And another question, if I want to make bromine at this position, it is benzylic to this benzene ring and allylic to this alkene. Then what you have to do? So there are two methods. Usually you can directly use bromine in presence of light, but this bromine in presence of light gives aromatic halogenation also. The common reagent used for the benzylic and allylic bromination is N-bromosuccinamide, NBS, in presence of UV light. N-bromosuccinamide in presence of UV light, you are going to get this bromine at this position. It is very, very important, students. So if I want to make bromine at this position or at this position, Markovnikov's product, you have to use only HBr. If I want to make bromine at this benzylic position without disturbing double bond, I have to use N-bromosuccinamide. Or you may be given like this, bromine in UV light. Then also it gives benzylic bromination, but there is a chance of getting mixture of this aromatic bromination. So this concept is very, very important. Next, Why is sulfuric acid is not used during the reaction of alcohols with potassium iodide? Just what I said, sulfuric acid cannot be used along with potassium iodide in the conversion of an alcohol. Yes, students. An alkyl iodide as it converted potassium iodide to corresponding acid. This HI, this is HI is hydroiodic acid, is then oxidized it to iodine, where this iodine gives back the reaction, back reaction. Write structures of different dihalogen derivatives of propane. So you can write dihalogen derivatives. And among the isomeric alkanes of molecular formula C5H12, identify the one that on photochemical chlorination yields a single monochloride. Yes, so this is, even if I substitute at this position, sorry, this position or this or this, all are similar compound or are same compound. We have the 3 isomeric monochlorides. So this is one type. Yes, so this is secondary and this is secondary. So these 3 chlorine compounds are different. When it comes to 4 isomeric monochlorides, so this is one type, right? This is another compound. What we are going to get, this is another compound and this is another compound. 4 isomeric compounds. So let us concentrate here, students. So the very important questions. So alcohol, this is alkyl alcohol, right? Cyclohexanol, upon treatment with thionyl chloride, it simply gives chloride. Then comes bromine, heat or UV light. Just now what I said, bromine in presence of UV light, what is going to happen? Is it going to brominate this benzene or benzylic position? So concentrate on UV light. Whenever you see UV light, it is undergoes or it gives benzylic bromination. Benzylic bromination. If instead of this UV light, if you find iron, then do the halogenation on benzene ring. So bromine, UV light or heat or light, then do benzylic bromination. Similarly, right. So HCl, treatment of HCl with benzyl alcohol, and here you may come across this phenol. Is it phenol going to replace or displace with chlorine with simply treating with HCl? No. Phenols are intact to HCl acids, right? So it is going to give only benzyl chloride. It is not going to give this. Phenol is intact. Phenol is not going to be disturbed. Yes, students. Next, it is very important. Let us see, when I treat with HI, so is it going to attack this side, iodine, or this side? So Markovnikov's product, what it says, let us write Markovnikov's product. So methyl here, if I add hydrogen here, H plus here, and it is going to form this carbocation. What is the carbocation here? Secondary carbocation. So if I add hydrogen first to this carbon, and what is the carbocation formed here? It is tertiary carbocation. This is secondary carbocation. This is tertiary carbocation. We know that which is more stable? Tertiary carbocation. So the incoming iodide or nucleophile will add to this tertiary carbocation, which gives major Markovnikov's product. Yes, iodine is added to here, right? Sodium iodide, what is going to happen? This is Finkelstein reaction. Bromine is replaced with sodium iodide in presence of, let me write acetone, dry acetone. Use dry acetone here. It is going to give ethyl iodide. Next, so bromine, UV light. Now your knowledge comes, your idea of allylic bromination and benzylic bromination. So it is very similar. Benzylic bromination, and this is allyl position, and this is also allyl position. Yes, students. So UV light, where it undergoes, it is not going to undergo If I use bromine in CCl4, for example, if I use bromine in CCl4, what happens? I will get dibromo compound. Yes, trans dibromo compound I am going to get. Bromine CCl4, I am going to get dibromo compound, bromine in CCl4. However, I am using bromine in presence of UV light, it undergoes allylic bromination. This allylic position is going to be halogenated. Allylic bromination takes place. Next, so this is how you can come across number of reactions. So what are the physical properties? It is very important, students. The boiling points of alkyl halides increases when moving from top to bottom. That means, for example, methyl chloride, methyl iodide. Yes, so methyl chloride is a gas. This is liquid at RT. It is a gas. So this is how moving from same alkyl group attached to fluorine, chlorine, bromine, iodide, then the boiling points are increases from moving top to bottom. Next, and it is another important factor, or the concept is the boiling points of straight chain alkyl halides is more when compared to the side chain containing or isomeric alkyl halides. So for example, this 1, 2, 3, 4, 1 bromo N butane boiling point is higher than tertiary butyl bromide. Yes, students. Next, and when it comes to aromatic compounds, this para dichloroarenes are going to have higher melting point, because in crystal structure this para dichloro compound easily rearranges, tightly packed arrangement takes place in crystal structure. So that is why it will have higher melting points. Otherwise, so boiling points are very near. Boiling points will not have that much difference. However, melting points will have difference when it comes to ortho disubstituted chlorobenzene to para. So para position containing halogens will have higher melting points. Then bromo density. Yes, so density is, don't worry about this one compound. So most of the halogen containing compounds are denser than water. That is why when you take these halogen compounds in separating funnel, the layer which is downside is halo compound and this is water layer. It is water, and water comes above the halo compound. For example, if I take dichloromethane, for example CCl4, let me take CCl4 or chloroform. So chloroform, if I take chloroform, this is chloroform is down and water is going to be upper layer. Water will be upper layer. So chloroform density is more than this. So that is why these compounds are used, which gives layer formation, and these compounds are immiscible with water. So in organic chemistry, these solvents are used as solvents for extracting the organic compounds which are there in the water. Right, students? So arrange each set of compounds in order of increasing boiling points. Just now what I said. So bromoethane, bromoform, chloromethane, dibromomethane. So chloromethane will have lowest boiling point, then followed by bromomethane, then dibromomethane, and bromoform is nothing but tribromo. So bromoform, like that. So chloromethane lowest boiling point, followed by bromomethane, dibromomethane, and bromoform. Yes. So similarly isopropyl chloride, 1 chloropropane, 1 chlorobutane, like that. So isopropyl chloride and branch lowering boiling point, then 1 chloropropane. Yes, students. So this is how it is going to give. Yes, students. We will learn chemical reactions in next class. Till then, have a break. Bye students. Thank you for watching this video. Please subscribe my channel Venus Academy if you are not yet subscribed, and don't forget to click on like button and bell button. We will meet again with chemical reactions of haloalkanes and haloarenes. Thank you students. Thank you for watching this video. Please subscribe my channel Venus Academy if you are not yet subscribed, and don't forget to click on like button and bell button. Bye. Sayonara. Arigatou gozaimasu. All the best.